homogeneous linear differential equations. These are equations of the form of f kx ky equals to f into brackets x y. To solve, we substitute y equals to vx and dy over dx equals to v plus x dv over dx. So what if we start by an example? You have been told, find the general solution of x squared equals to y squared dy over dx. So we want to be left with dy over dx alone, and also x and y are on one side, so it will be dy over dx equals to x squared over y squared. So to prove it's homogeneous, we are going to write f xy equals to x squared over y squared. So f brackets kx ky equals to kx squared over ky squared. This k and this k cancels. You're left with x squared over y squared, and as you can see, f xy equals to f into brackets kx ky, thus proving it's homogeneous. So we go into substituting it, and you have seen when we want to substitute, we're going to use y equals to vx and dy over dx equals to v plus x dv over dx, and our equation is dy over dx equals to x squared over y squared. So where we have dy over dx, we replace it, we substitute it with v plus x dv over dx equals to, where we have y, so it will be x squared, and the value of y we have seen equals to vx, so vx squared. Here we can cancel out, since here there is an x squared and also here there is an x squared, so we're going to be left with v plus x dv over dx equals to 1 over v squared. So we can be left with x dv over dx equals to 1 over v squared minus v. X dv over dx equals to 1 over v squared minus v. So we first work out this 1 over v squared minus v over 1. So here it's v squared, our LCM will be v squared. V squared divided by v squared is 1, so it will be 1 minus v squared divided by 1 is v squared multiplied by v, it will be v cubed. Yes, so our equation will be x dv over dx equals to 1 minus v cubed over v squared. So this is our equation, this is what we're left with, and we want to have x dx on one side and dv on this other side, so we can multiply this side by 1 over, let me do it here instead, can be 1 over dv multiplied by x dv over dx equals to 1 minus v cubed over v squared. So this dv and this dv cancels, so we are also going to multiply this other side by the dv. So we are left with x over dx equals to 1 minus v cubed over v squared 1 over dv. So we can solve this by writing v squared 1 minus v cubed dv, and here it can be dx over x. Yes, so let's continue solving it. So when we're left with it like that, let me write it here again. Dx over x equals to v squared over 1 minus v cubed dv. We can integrate on both sides, this side and this other side. So here it's like dx multiplied by 1 over x, and you've been told to integrate it. So 1 over x, it will be ln x. You can write it just like that, and then we go and start solving this other side. So we have already integrated this side, so let's go to this other side. Been told integrate v squared over 1 minus v cubed dv. So our u will be 1 minus v cubed, our du will be negative 3 v squared dv. So the value of dv will be du, which is negative, over 3v squared. So we're just going to continue integrating it. V squared over u over du over 3v squared, which is negative. This v squared cancels out with this v squared. We bring the negative 1 over 3 out here. We are left with integrate 1 over u du. So it's going to be negative a third ln u. Our u is 1 minus v cubed plus c. So we are going to join the two equations together, whereby it will be, it's going to be ln x equals to negative 1 over 3 ln 1 minus v cubed plus c. So I know some of you are wondering, why are we not adding plus c on this other side? We can't have two constants in the same equation, so that's why we add on only one side. So, and as we saw that our equation was y equals to vx. So the value of v will be y over x. So we are going to substitute the value of v here, so that it may be ln x equals to negative a third ln 1 minus y over x cubed plus c. Let's try another example. So find the general solution of x minus y plus x dy over dx equals to 0. So our equation will be left as dy over dx equals to y minus x over x. So we are going to prove it if it's homogeneous. equals to fxy. Okay, so we are going to add ky minus kx over kx. So that's our equation. To the k out, it will be ky minus, this should be an x, minus x over kx. So this k and this cancel, so we are left with y minus x over x. That's proving it's homogeneous. So we're going to substitute in it, and we saw that y equals to vx, and v plus x dv over dx equals to dy over dx. So we are going to substitute it into our equation. So it will be, it's going to be v plus x dv over dx equals to our y, plus it's vx minus x over x. That's how it is. So it is v plus x dv over dx equals to x v minus 1 over x. This x and this x cancels out, so the equation remains as x v plus x dv over dx equals to v minus 1. We can bring our v here, this other side, so we are left with x dv over dx equals to v minus 1 minus v again. So v minus v, it will be 0, and then you're left with negative 1. So let's come here. It's x dv over dx equals to negative 1. So we bring our dv into this other side, so we are left with this side, it will be x over dx equals to negative 1 multiplied by 1 over dv. Will be x over dx equals to negative dv. So dx over x equals to negative dv, since this is a negative, and when you integrate this side and this other side, you're going to be left with ln x equals to negative v plus c. Ln x will be equals to, and as we know, y equals to vx, so the value of v will be y over x, which will be negative y over x plus c, and that's our answer.